Today I'll be talking about the 2016 AP Chemistry FRQ number 3. For part A, the question asks if metal M is given an axis, can we calculate the number of moles I2 has reacted? From above, we know that after the reaction occurs, all of I2 has reacted to create Mi2 aqueous, leaving only M. And if we use the mass of beaker plus metal M plus I2 minus the mass of beaker plus metal M, we should get the mass of I2. And if we convert the mass of I2 into moles, we should get the correct answer for part A. And 1 point is earned for the correct number of moles. For part B, the question asks if we can calculate the molar mass for the unknown metal M. And we know that molar mass is grams over moles. So we can get the grams of metal M if we use the mass of Mi2 and divide it by the mass of I2, and that is the mass of metal M. And the number of moles for metal M should be the same as the number of moles for I2 because it is a 1-to-1 ratio. And if we divide 0.263 by 0.004023, we should get the correct answer for part B. And 1 point is earned for the number of grams for M, and another point is earned for the molar mass. For part C, the student hypothesized that the compound formed by this reaction is ionic, and the question asks how should the student perform an experimental test to support his thesis. What I think the student should do is that he or she should dissolve the compound into water to see if the solution conducts electricity, because ionic compounds will all break apart when they dissolve in water, and the mobile ions created can carry charge very easily, which will make the solution electricity conducting. And that is the best proof that the compound formed by the reaction is ionic. And for this question, 1 point is earned for the appropriate test, and another point is earned for the explanation. For part D, the question asks why I2 is the solid while at room temperature while Br2 is still a liquid. And what I think is that I2 and Br2 both has LDF as their only intermolecular force, and I2's LDF should be stronger than Br2's because I2 has a larger atomic size and therefore it has more electrons, and by that means I2 should have a stronger LDF and it should have a higher melting or boiling point than Br2, and that's the reason why I2 is still a solid while Br2 is a liquid. And for this question, 1 point is earned for identifying the intermolecular forces for I2 and Br2, and another point is earned for explaining why the forces are stronger in I2 than in Br2. For part E, the question asks which one of these three solutions should the student add to I2 to reduce it to I-, and I2 will reduce to I- if the reaction is thermodynamically favorable. And what I did is I calculated the E value for 3 of the solutions and compared the answers. For H2O2, the H2O2 is on the wrong side of the equation. We should flip it to the left side because we are adding H2O2, we're not producing H2O2. So if we flip this equation, this would become negative, and the answer should be negative 0.14. And for the second one, Na2S2O3 is also on the wrong side, and if we flip this equation, this would be negative, and the answer should be positive 0.46. And for the third one, Na2S2O6 is on the correct side, but we have to flip one of the equation because not both of the equation can be reductions, and we can only flip this one, and the answer this will become negative, and the answer should be negative 0.46. The correct choice for the solution should be Na2S2O3 because it has a positive E value, and if we want the reaction to be spontaneous, we need delta G to be negative. So using a positive E value should get us a negative G value, negative delta G value. And for this question, 1 point is earned for the correct choice. And for part F, the question asks us to write a net balance equation for the reaction between I2 and the solution we selected in part E. And we should use I2 plus, and we flip this equation, is 2S20 free 2 minus, and we will produce 2I minus, and then is S406 2 minus. And another point is earned for the correct equation.